Good morning, good afternoon, and good evening. My name is Rebecca Patrick, and I'm from CAFIA, which is the Council of Academic uh, Public Health Institutions Australasia, and I co-lead the chairing of the Climate and Public Health Education Network. And I'm absolutely delighted to be here this evening for me here in Melbourne, or otherwise known as NAM in local Indigenous languages, to facilitate session 7, Public Health Strategies for Droughts and Food and Water Security, as part of the Climate Ready Classrooms, a public health faculty development course on climate change. So, just some housekeeping before we head straight into the fantastic session that we have ahead of us. For English captions, just click on the CC button on the bottom of the Zoom window. If you would like to understand in Spanish, please click on the link in the chat to access this. And I'm anticipating my wonderful colleagues are doing all of those things in the chat for you as I speak. So where are we? We have come a long way already together. We are now in session 7, Public Health Strategies for Droughts and Food and Water Security. And we are now deep into the program, and I understand we have more than 3,000 participants across time and in the various sessions. So set to be another fantastic session ahead of us today. So every week we just touch base with the course objectives, and here they are on the screen. So we're here to equip public health faculty with a deep understanding of the science of climate change, its drivers, and its direct and indirect impact on health, and of course enabling them to confidently integrate climate health concepts into existing public health curricula. Also preparing us as educators to guide students beyond the theoretical base towards that much more applied skills in risk assessment, working in the health system context, as well as community engagement and evidence-based interventions. The session learning objectives that we're tracking over the course of the next 90 minutes are here on the screen. I'll just take a pause while you track your eyes over the screen, but I will give you the highlights as we go. So we're explaining temperature, droughts and precipitation as it relates to food security and nutrition, looking at evaluating the associated risks across a range of contexts, explaining how climate change affects various dimensions of food security, stability, access, utilisation, exploring the mechanisms for forecasting in food security, and exploring strategies to enhance food security in this context. And finally, describing the relationship between agriculture, greenhouse gas emissions, and the co-benefits of dietary changes to mitigate climate change. So every part of this conversation is available to you this evening, and we anticipate that we will hit on all of these learning objectives with the 3 fantastic speakers that we have online this evening. So just a couple of logistics. Like I said, it's a 90-minute session. We're going to hear from 3 fabulous people, and I'll go through their bios very shortly. We're going to have an expert lecture coupled with 2 case study presentations. The session will culminate with a question and answer section, and you'll be able to use the tools that are handily available to you on Zoom to engage in that conversation and offer some questions up. We will be recording as per the announcement when you jumped online. There'll be slide decks and resources to share. But of course, you must be enrolled on the Canvas page, and there's instructions on enrolling in the chat. So that's the logistics. As you can see, attendance will be tracked. So in order to receive that wonderful certificate of participation, we do track your attendance either automatically when you jump into the Zoom. We already have 741 of us today. Otherwise, if you're participating via the Canvas platform, you'll be also logged using your same email address as the registration. So really important that that you get that recognition for your participation. And so how do you qualify for that certificate of participation? Participants who attend or review 8 or more of the 11 sessions and pass a final exam with at least a 70%. So in the Australian context, that is a distinction or above. You'll be awarded that certificate of participation in this climate and health course. So there is a community of practice that wraps around this. So pick up your phone, scan the code, and join the WhatsApp group to receive important course information and reminders, and become a part of this community at your very fingertips. Okay, so that's logistics on what's up ahead of us in just under 90 minutes. I will just outline who we've got that's going to be presenting today, and just as each presenter comes to the fore, I'll give you their deeper bio. But we have Sari Lucille Blakely, as you can see, who'll be taking our lecture this evening, and then we have Sharad Sukla, as well as Catherine Jones. So in a moment, I'm going to hand to Sari, but let me tell you just a little bit more about this incredible climate and health person before we hand over. So Lucille is an associate research scientist in the Columbia Climate School at Columbia University, studying how climate, weather shocks, gender, and time use impact food security. She's worked with a variety of non-government organisations, local governments, and research institutes to develop strategies to manage extreme weather events through analysis of worst rainfall years on record, evaporative transpirative demand. And Lucille, can you help me out when you pick up the mic and tell me how to say that properly? Assessments of vulnerable parts of the cropping season, extreme heat impacts on vulnerable populations, and educational tutorials for risk management. Her main focus has actually been in West Africa, but's worked across all parts of Africa, Asia, the Caribbean, South America, and the United States. Sari's worked as a postdoc at the University of California, Santa Barbara, on a project funded by AUSSE's Feed the Future Peanut Innovation Lab before joining Columbia University. Sari Lucille Blakely, we'd love to hear from you. Over to you, and thank you very much.
What a wonderful introduction. I'll say good day, everyone. I'm not sure where everybody's calling in from. I'm calling in from the East Coast of the US, so it is morning for me. And like I was introduced, my name's Sari Blakely. I'm a researcher at Columbia University, and I focus mainly on how climate variability and climate change impact food security. And so I'll be talking to you about climate change and its impacts on water and food security for vulnerable populations. So just to get started, I want to start with a quick overview of what I'll be talking about today. I'll be starting off by talking a little bit about climate change, a very brief introduction. I'm sure all of you have already had a couple of brief introductions throughout this course, but I want to make sure that we're all sitting on the same starting point before we dive into what is food security, what does climate change mean for food security, how the changing climate causes risks, and what food systems and climate feedbacks exist. I'll be wrapping up this talk a little bit with how we can use forecasting to help improve food security itself. And then I'll be finishing out with talking about how we can, as people on this planet, enhance food security for all. And I want to start out with this one quote before I start talking about anything else. This quote is from 1988, and it is, I think, really useful for framing how we should maybe think about food security. It says, "A country and people are food secure when their food systems operate in such a way as to remove the fear that there will not be enough to eat. In particular, food security will be achieved when the poor and vulnerable, particularly women and children, and those living in marginal areas, have secure access to the food they want." And I think this is an important starting point for all of us to think about. I think a lot of us consider food security when you have enough to eat. But what does that mean to have enough to eat? In my opinion, it's more than just, is there food in front of you? I think it matters if you think about, tomorrow, am I going to be able to go into the grocery store and buy all the food I need for me and my family? I don't think it's enough to say there's food in front of me now. I think there's a security in knowing that there's going to be food in front of me, and there's not going to be this gap between when I have the food I want to eat and when I don't. And I do want to highlight that food that you want is also what I consider a part of food security, meaning that you're not accessing food you don't want as part of food security. You're accessing food you do want, food you can use and make meals that you like with. And so then to hop into what is climate change, like I said, I'm sure that all of you have had some sort of orientation on what is climate change. I'm going to just start by saying climate change generally is defined as a long-term trend in the state of the climate. But that's not enough to describe what we're experiencing now. What we're experiencing now is this long-term increase to global surface temperatures induced by human activity since the 1750s, roughly associated with industrialization. This is due to an increase in greenhouse gases in our atmosphere, things like carbon dioxide, things like methane. And I want to highlight that greenhouse gases in and of themselves are not bad. They're fine. That's actually how we have a planet that we can live on. Otherwise, our planet would be very, very cold. And so having an excess of what we need to have a warm planet, that's where we start having the issue with global average temperatures increasing over time. You can see in this graph to the right of the screen, this long-term increase with post-2000, a very large jump in increases in temperature. These increases in temperature don't stop at temperature increasing. It actually causes changes in precipitation timing and intensity. It causes things like rising sea levels. These have physiological effects on crop development, which I'll get into a little bit later in this discussion. And it has direct and indirect impacts on our food security as a globe, not just one individual's, but everybody's food security. And so then what does it mean to be food secure? Well, there's roughly the same translation across many different organizations. I'm highlighting here the World Bank, the World Food Programs, and the USDA's, but there are key differences across all of them because they have context meaning. So starting with the World Bank's definition, its food security is defined when all people at all times have physical and economic access to sufficient, safe, and nutritious food that meet their dietary needs and food preference for an active and healthy lifestyle. The World Food Program defines food security as when people have access to enough safe and nutritious food for normal growth and development and an active and healthy lifestyle. USDA defines food security as access by all members at all times to enough food for an active, healthy life, at minimum, the ready availability of nutritionally adequate and safe foods, assured ability to acquire acceptable foods in socially acceptable ways. And I want to point out that while there are themes across all three of these specific definitions that are in common, things like safe and nutritious food, there are definitely differences between each of these definitions. The World Food Program, for example, highlights normal growth and development, which is associated with their mission of making sure that families, in particular children, have enough food to grow in a normal way. The World Bank highlights physical and economic access as part of food security, meaning that this is in line with, once again, the World Bank's mission of having economic interest in food security. And then USDA highlights acquired in acceptable foods in acceptably social ways. So highlighting that it's not just, do you have food in front of you, but can you get it in a way that is okay with both you and food that you want to eat? And so I just want to highlight these three definitions. While they have quite a lot in common, they do also highlight different aspects of food security, and they're not reflected universally across all three of these definitions. Generally speaking, food security usually is identified through four pillars of food security. It's food availability, food access, food utilization, and food stability. This was adopted during the 1996 World Food Summit. And let's just dive right into each of what these definitions actually mean. If we talk about food availability, this is asking the question, does the food exist locally? So what we're looking at is there food that you can access? Is there food available to you? Is there sufficient food available to you on a consistent basis? And it implicates food production, such as crop production and livestock production and fishery production, as well as wild game, in this question. It also includes things like processing and packaging, transportation, storage, and trade systems. So quite a lot goes into food availability. So where is this food that's in front of you coming from? Food access is asking the question, if the food exists, can you get it? So the previous one was asking, does the food exist? Is it in the area that you live in? The next question is, can you get it? So do you have the resources necessary to acquire this food? This is including things like food prices and proximity to food, as well as retail outlets and farmable lands. And this is also looking into whether social and cultural norms are shaping your food distribution, specifically within household and within your community. So this is not just asking, like, if you're at a grocery store, is there food? It's asking, if you're at a grocery store and there's food, can you buy that food? Is it available to you for what you are living in and how you can get it? The next question is food utilization. So if the food exists and you can get it, can you make use of it? So this is asking about an individual's ability to use the food that is available and accessible. It's asking if this food is safe and nutritious, and it intersects with things like storage, processing, packaging, transportation. So it's, once again, if we go back to this grocery store example, if you're at a grocery store and there's food and you can buy it, is there a high risk that it's spoiled? Is there a high risk that you don't know how to use this food? So you bought, say, jalapeno peppers, and you're assuming that you can just go ahead and throw it into any meal and it'll just make things better, but turns out you don't really like spicy food. You can't really use that jalapeno pepper then. And so that's what food utilization is asking, you have access to this food and it's there, but are you going to be able to make use of it to eat it? The final pillar is food stability, which is asking the question, if the food exists and you have access to it and you can make a nutritious meal from it, is that food consistently available? So this is asking, say you're at the grocery store and today there's apples. Are there going to be apples there tomorrow? And so this is very much an immediate, is there food there on a consistent basis? And this is one place where climate change has a large impact. It impacts stability through things like weather shocks and disasters. And this touches on things like food supply chains, food production, food storage, food prices. This touches on quite a lot of different aspects of the food system. So we're talking about whether that food is going to have, vulnerabilities or risks that it's going to get spoiled before it gets in front of you. This is talking about whether the food supply chain is going to get interrupted, say, by a storm, and then that food can't get in front of you. This is also asking things about how food is created. Is there going to be enough food created initially in order to get to you in front of you so you can eat it? Those are the four pillars. So those are the basis a lot of what food security is generally based upon. But there's suggestions to add more pillars to these food security pillars. So once again, if we go back over them, the four were stability, access, utilization, and availability. But beyond that, people talk a lot about these other three options, and I'm going to say this is non-exhaustive. These are the three that I come into contact the most, but there are more pillars than just these three as well. So if we look at this first one, there's agency. So can you advocate for other foods, nutritious foods, or food safety? So this is asking in the system that you are currently in, once you have come across, you have access and available food, you have nutritious food that you can use, and it's there consistently. This next question is asking, can you advocate for other foods? Can you say, I don't want to have these foods in front of me. Can I have different foods in front of me? Are you in a safe enough system that you can say, I want something else? The next question is on sustainability. And this is the system that exists robust to climate change, political change, or economic changes? And so stability and sustainability feel like they're answering the same question, but they're not. I consider sustainability more a long-term question as opposed to stability, which is a short-term question. Stability is asking, today, is there food? And then is there going to be food tomorrow? But sustainability is asking this question, there's food for us today, but in 10 years, is there going to be food for us? Is there going to be food for my children? And that's really how I think of sustainability, is this long-term, very more large question about how the total system looks than just how from day to day, how that system looks. And then the final pillar I'm going to suggest we consider is acceptability. So the food that is available and accessible and usable, is it acceptable to our needs? You can think of this in terms of dietary restrictions. So if I am, say, a vegetarian and I go to the store and all they have is meat products because they ran out of all of the vegetables and fruits, technically I have food and it's consistent and it's available and I can buy it. But would I want to eat that if I'm a vegetarian? And the answer is no. I wouldn't want to eat a whole bunch of, say, pork products if I happen to be a vegetarian. And so this is really important when we're talking about food security, because a lot of times it goes as like an aside, like, oh yeah, and I guess we need to make sure that that food is acceptable. But this is really, like, in my opinion, needs to be very high up, just because a lot of food interventions forget to take into effect if people are going to want to eat it. And if they don't want to eat it, then they're not really food secure. Okay, so those are the pillars. Those are different aspects of the food system and how food security intersects with each of these pillars. If we go over back to climate change, if we just are talking about how climate change is impacting weather, and I'll tie all of these together in a moment, but if we just consider how climate change is impacting the weather we're experiencing, we're thinking about things like increasing temperatures during the day and at night, which is going to do things like reduce frosting, and that's going to change the timing of crop growth. Also, climate change impacts rainfall regimes. And so you're experiencing more unpredictable rainfall. And with that comes an increased frequency of drought and wildfires. There's also an increased frequency of extremely high rainfall events. And these, before we talk about specifics, do impact overall the food system through impacting crop growth, through impacting livestock, through impacting fisheries. And so it has a lot of impacts just on the supply side of our food system. If we think about how specifically climate change is impacting our food system, we're thinking about things like there's altered food production. And so there could be things like larger crops that don't have as much nutrients if it's growing very fast. And that's something that is expected. We're also talking about water changes. So the water quality that you're getting, does it have, is it free of toxins? Is it good water to drink? Well, that is impacted by climate change. Additionally, there's things like infrastructure disruption. So if there's a large hurricane that comes, it might destroy some of these storage zones, and that will reduce food security. There's things like people are moving because of impacts to their food production. And so that's creating vulnerable populations that are moving in order to find better food security, who might be at risk of finding less food security. And then finally, there's something called pathogen vulnerability. This means basically that our food system is highly, highly susceptible to pathogens, things like pests and disease. And with climate change, there is impacts on how pathogens are affecting our crops. And so if we look more specifically at things in terms of the 4 pillars, we can see climate change and food availability is resulting in things like decreased crop yields, livestock productivity decreases, and changes in optimal growing zones. So places that are growing foods that we enjoy are potentially being moved in maybe northward. We can think about maybe a very specific example in grapes. Wine growing regions are moving northward. And that's a problem because, grapes, they take a long time to mature. And if we're talking about a wine zone moving northward, there's going to be fields of grapes that are no longer viable. And there's going to be places that aren't growing grapes yet. And so there's going to be a direct impact on the availability of wine. And we're talking about climate change and food access. There's a direct impact on infrastructure. I use the example of things like hurricanes, which hurricanes can increase in intensity under climate change. And if that's affecting infrastructure, it could wreck, say, a stockage warehouse, or it could affect transportation lines, or it could just really ruin, indirect effect on crops itself. All of these things will increase prices, which will make food less affordable. If we think about climate change and utilization, we're talking about things like an increased rate of spoilage. So if temperatures are rising and we're thinking about foods that are things that need to be refrigerated or things that need to be eaten quickly, if temperature is increasing, all of those foods are going to go bad quicker. We're also at risk of higher contamination. So there's bacterial, fungal, algal blooms. All of those can directly infect our foods and make it so that we can't eat it anymore. We also have contamination from heavy metals. So with climate change, there's an increased rate of uptake of heavy metals in crops, which means we can't eat those crops because we can't consume heavy metals. If you think of, say, mercury in the oceans, well, with climate change, the ice caps are melting. There's mercury being released at a higher rate into the oceans, which means fish are consuming it, which means as the fish are eaten by larger fish, get to the point where we eat, say, something like tuna, it's consumed quite a lot of heavy metals at that point. And then overall, the nutrition of the food itself that we're eating could be decreasing. I mentioned earlier that crops could be growing at faster rates. That's true under climate change with increased carbon and increased temperatures. Crops could be growing a little bit faster and get bigger. The downside to this is that it could be, instead of pulling up nutritions from the soils at a good rate, it could be insufficiently pulling up those nutritions that we want to have in our food, which would result in less nutritious food overall. And then finally, climate change and instability. Well, we're talking about disruptions at multiple levels to the food value chain. We're talking about disruptions at the crop level. We're talking about disruptions at the infrastructure level. We're talking about disruptions at the utilization level. And then being able to ensure that we have that food tomorrow, what we have today, well, that's less and less obvious how we're going to ensure that given all of these other impacts on our food system. I'm going to talk about a couple of very specific climate change and food security items. We're going to talk about agricultural productivity, soil and water resources, as well as agricultural workers' health. And I want to highlight this last one because that's important for how we're getting our food in front of us. The two images you're looking at are rotted tomatoes and infected groundnuts, both of which have a higher risk of getting contaminated prior to consumption. And so if we're talking about changes in agricultural productivity, we're talking about things like temperature, rainfall, and frost-free days are changing, leading to potentially longer growing systems, and that could have both positive and negative impacts. One of the big things is with changes in rainfall, we might be relying more on irrigation. We might also have a higher risk of things like wildfires that would destroy our crops. Wildfires themselves cause air pollution, which can cause damage to crops, plants, and forests. And then temperature and precipitation changes can also expand the occurrence and range of insects, weeds, and diseases. And so then we might be seeing a larger need for pest control. With warmer waters and precipitation changes, with warmer temperatures and with precipitation changes, we can see changes in when plants bloom. And there's the potential for when things like that change, pollinators might not come out at the same time. And we might see the potential for a larger mismatch. And that's worrisome because we need these pollinators to pollinate our foods. Heat can directly affect the productivity and health of animals. Higher temperatures are associated with less healthy animals, which will affect our livestock. And then with all of these things, if there's, say, lands that are, degrading due to, say, wildfires or due to, say, larger use of pest control or more intensive crop growing, we could see increased deforestation related to that. So finding new lands, new arable lands for farming, and abandonment of older lands, which would lead to more deforestation and therefore affect places that are at risk of deforestation. South America comes to mind. Sub-Saharan Africa has some places that are also deforesting at a larger rate. And so just lots of things can happen within agricultural productivity that can lead to negative impacts, not just on the food system, but on the globe. There's also direct impacts to soil and water resources. If we're talking about extreme precipitation, this can erode soils and deplete the soil nutrients. And so once again, heavy precipitation is more likely under climate change and therefore could impact directly our lands that we're growing on. With this heavy precipitation could have increased agricultural runoff into oceans, lakes, streams, and that can harm water quality. Increased runoff can lead to depleted oxygen levels. And if you couple that with increased temperature, you experience hypoxia, which can kill fish and shellfish. And then sea level rise can threaten coastal agricultural communities by eroding and having agricultural land losses. And there's also something called saltwater intrusion, which is basically when saltwater is impacting freshwater resources, resulting in fresh water that we can no longer use. So brackish water. And then I'm going to just talk briefly about agricultural workers' health. Agricultural workers are important, really, really important to our food systems. We almost talk about food productivity as if it is without food workers, but agricultural workers are a large part of our system. We rely a lot on them in order to have the food in front of us. Agricultural workers themselves, they're going to experience heat exposure, which can lead to things like heat stroke. And that's very dangerous to experience. It's important to recognize that we need to find some sort of protections for these workers in order to make sure that they can keep working in a safe way. They're also exposed to things like extreme weather events. They're exposed to increased pesticide use in order to make sure that the foods we're eating are pest-free. They're exposed also to disease-carrying pests themselves, and with things like wildfires, they're experiencing degraded air quality. And so that's going to increase our food prices because there's going to be fewer workers willing to work in these environments. and that's going to raise the prices of foods overall. And so just to keep in mind that agricultural workers need to be protected in this environment, because it's already a difficult environment to be working in. And when you couple all of these changes from climate change into how these workers are experiencing their days, we're going to be seeing increased exposures across the board of people who are vulnerable. All right, just to jump into how the food system and the climate system feed into each other. I want to set the stage with talking about how 40% of ice-free land is actually currently dedicated to agriculture or livestock. And so agriculture currently is quite a big emitter. It accounts for about 25% of global emissions. And if we don't change the food system itself, the agricultural impacts are going to continue to increase. So we're going to see a growing food demand because of increasing population. As we see increased economic development, we're going to see income-associated dietary changes, which also will impact the environment. And 1% of 1 degree Celsius of warming is associated with a 3 to 7% decrease in global crop yields. And so I just want to talk quickly about how this food system and the climate system are related. The climate system, because 25% of our global emissions can affect from agriculture, this means that when we're doing things like growing livestock, which is a high emitter, it's going to make climate change, it's going to accelerate climate change. Well, climate change is going to double back and increase that the cost of raising that livestock. And so then we're going to invest in other things that will potentially impact the climate system. So doing things like increasing the arable land for this livestock in order to make sure that they have the productivity. Well, that's going to have another feedback on the climate system. And so it can create this negative feedback loop where impacts to the climate system cause us to take changes to the agricultural system or the food system, which are going to increase our emissions into the climate system, which will come right back and make us need to do something for our food system that may increase our emissions. And so it's a loop that can really feed into itself. With these feedback loops, we can see things like productivity losses. We can see an increase in pesticide use and therefore pesticide pollution. We can see changes in water availability leading to water scarcity. We can see changes in soil degradation. We can see changes in biodiversity loss. And all of these things are interrelated and connected and can feed back into each other very quickly. And so we're going to move into the part of this talk that's hopefully a little bit more hopeful. We're going to talk first about forecasting and food security. And so forecasting, you really can use many types of forecasting products to implement strategies to improve food security. And there's a lot of different forecasting levels. There's things like seasonal, subseasonal, weather, and food security outlooks. And I believe we're going to have a little bit more discussion on these specific topics later on, but I want to just touch on what these different types of forecasting products can do. So if we're talking about seasonal and subseasonal forecasts, these are forecasts that are long range, meaning that we can take them at many months out for seasonal and several weeks out for subseasonal. And we can use these types of forecasts to help plan action. I've been involved in a couple of different projects called anticipatory action, where they specifically use, in my case, seasonal forecasting in order to activate actions that reduce the impacts of whatever that forecast is. A lot of times this is related to drought. In West Africa, it's almost exclusively related to drought, although there's talk about flooding forecast. And obviously there's also things like subseasonal hurricane forecasts. And so the basic idea of this is that ahead of a crisis, you're using a forecast to reduce the impacts. There's a lot of evidence that it's cheaper to do something ahead of a crisis to reduce its impacts than it is to have a reactionary intervention. And so the idea is something like you have a forecast 3 months ahead of time for a drought. So you know in March that there's going to be a drought in June. So what you do is you start distributing things like drought-resistant seeds. You start doing things like helping create water pools so that way you can irrigate, etc. And so basically you're trying to ahead of time prep for this drought. So that way when the drought actually happens, you've already prepared for it and you've reduced its impacts. A lot of these are, the idea is that you're just going to be setting up these systems so that way when the forecast of a negative impact, say drought, happens, you can just act. You're not debating about what actions you're going to be taking. You're making a plan ahead of time for actions you can take to reduce these negative impacts. And you're effectively using this to try to help reduce food insecurity by using the forecast to guide these actions. The image you have on the right are anticipatory action projects across the globe affiliated with the UN OCHA system. There's a much larger number of projects than just these ones, but I'm using OCHA's because I happen to work with both OCHA and WFP on these projects. And then the next thing you can do is do something called food security outlooks. FuseNet makes one. There's also the Cadre Harmonisé in West Africa, which is similar to the food security outlooks made by FuseNet. And effectively what you're doing is you're describing the current and anticipated food security. Acute food security, there's long-term food insecurity, there's malnutrition. And so what you're doing is you're trying to figure out what is the current state and what is it going to look like a few months from now and evaluate what that magnitude and severity of food insecurity can be in order to create opportunities to address these food insecurity by doing early interventions. Of course, there's things that you can't always anticipate. A lot of conflict is difficult to anticipate, which does directly impact food security. But things like anticipating a long-term drought will have a direct impact on food security, and that's something that you can address more directly with these food security outlooks. Okay, and so then I'm just going to hop into the last bit of my talk, which is strategies for improving food security under climate change. So one of the big things is doing something called climate smart farming methods. So climate smart farming or climate smart ag, this is a term used to describe a lot of different types of farming methods that we can employ in order to help improve productivity, to help make the farming more sustainable, to help make sure that we're having a system that creates food that has minimal impact on the climate itself. And so one of the big things is to make sure that we're using forecasting tools to help make decisions about upcoming seasons, and also to do things like planting cover crops, which means that we're planting things that can help just renew the soil, make sure that the soil is as healthy as can be. We can do things like reduce runoff. Runoff can go put things like pesticides and fertilizer directly into water, and that can not only impact the water quality, but also impact other things like livestock and water availability for livestock. And then we can do things like strategically apply fertilizer. So not using cover fertilizer, but rather using fertilizer for specific key points of the season and specific key types of crops. We can do things like keeping livestock out of streams to make sure the stream quality stays clear and good. And then we can also do things like cross-pollinate different crops to make sure that they have good pest resistance in order to reduce pesticide use and also improve pollination. And these are things that, the majority of us maybe don't have a whole lot of hand in. This is a lot of things like we need to be focusing on local advocacy for climate smart farming methods in our communities to make sure that our communities are trying to improve the food system itself. But then there's specific things that we as individuals can do. And the biggest thing is perhaps preventing food waste. So food waste is, say you've got that lettuce that you bought last week, it's in the fridge, it's going bad, and you just toss it. This is contributing to, this is contributing potentially to climate change. We're growing foods we don't need. This is also potentially increasing things like waste. That's not good. And so instead of, having something go bad in your fridge, it's important to make sure that we try to use that and consume that. So that way it's not going to waste. So that's something an individual can do. Another thing an individual can do is consider some dietary shifts. If you look at this graph that I have on the right, we're looking at different types of diets. At the baseline, we've got meat consumption with vegetables, grains, and dairy products, as well as animal-derived products. And this has quite a large carbon footprint. But as you reduce your meat consumption, you see a big decrease in the carbon footprint. If you move all the way down to no beef or dairy, you have a much smaller carbon footprint. And then if you remove all animal products and go vegan, you have the smallest carbon footprint of all of the options there are for diets. And so these are things that we can do to help improve our climate system and our food system in order to make sure that we're contributing as little to climate change and helping improve food sustainability overall. And so with that, I will say thank you to everyone for allowing me to have this opportunity to talk to you about food security and climate change. And I'm not sure if it's questions time. I will leave that to the moderator.
Thanks, Sari. That was absolutely fabulous. What an incredible lecture, providing the foundations, really the building blocks of a very complex topic about a health determining sector, which is agriculture and food. So thank you so much, Sari. I think you've really set us up for the case study. You're absolutely right. We will circle back to you with regards to some great questions that are coming through. So maybe take a sneak peek at those in the back end and get ready for responding to those shortly. Thanks so much, Sari. Look, we'll keep moving into the case study space, and we are very fortunate to have Shraddha Shukla tonight, afternoon. Sorry, I keep forgetting that it's different time zones we're working across. Shrad is a researcher at the Climate Hazard Center at the University of California, Santa Barbara, so it's very early there. He's a large-scale hydrologist with expertise in drought monitoring and seasonal scale climate, hydraulic and drought forecasting. Actually is a civil and environmental engineering PhD from the University of Washington, has done a postdoc and is very focused on improving drought monitoring and early warning capabilities using advanced Earth observations, models and remote sensing data sets through capacity building, mainly in Africa. But I'm just going to hand right on over to you now, Shrad, to hear about your case study. Thank you so much. Over to you.
Yeah, thank you very much, Rebecca, for the nice introduction, and thank you all for being here. Let me start the presentation. Okay, I'm assuming that everyone can see it. So I wanted to first thank Sari for her nice overview and a very comprehensive background on acute food insecurity. That actually plays very well with what I am going to talk about here. So again, I am Shraddha Shukla. I'm a researcher at Climate Hazard Center. Sari has already talked about different aspects of how food insecurity early warning is conducted. This is just a very simple schematic that shows different components of the scenario development process for acute food insecurity early warning. It comprises of hazards, drought, floods, cyclones, earthquakes, disease and conflicts, and so on, and intermediate shocks like shocks on production, price, market access, All of that is combined with the livelihood zone, so which helps determine the socioeconomic vulnerability. And all of that goes into then providing estimates of food security outcomes at household level. So what our research center focuses on is mainly drought and flood monitoring and forecasting, and how drought and floods impact production shocks. So this is the aspect of this framework that my presentation will focus on. So just as an example, uh, in this case study, we will focus on anticipating production shocks to support acute food insecurity early warning. Just as an example, this is a schematic that shows the main planting season in Southern Africa. The season starts somewhere in October, ends in March and April. And what we do is we provide uh, uh, likelihood probability of the production shocks before the season starts. So this can be about 6 to 18 months before the main planting season in Southern Africa. And then we also provide production shocks during the growing season. Once the season has started, each month we provide a forecast of what the crop yield will be like. So these are the two different approaches that this presentation will focus on. There are differences in the methods and so on. What is common is that in each case, we make use of climate predictors to help anticipate production shocks. And here are two examples of what those products look like. On the left is an example that shows pre-season national level yield outlooks, and these are provided about 6 to 18 months before a growing season starts. This covers entire globe, and this is just an example of this a crop yield outlook. And in general, the places where you see yellow or brown colors, they are the places where there is higher chances of below normal crop yield. On the right is another product that we provide during the crop growing season. And as you can see here, the main difference between both of these products is the spatial scale. This product is available at national scale. This product is available at sub-national scale at different administrative units and so on. Another key difference between both products is that this product is based on ENSO forecast, and this product is based on machine learning models and several Earth observation predictors like rainfall and DVI temperature and so on. So I'll dig deeper into both of these products and try to describe the approaches we use for these outlooks. So starting with the anticipation of production shocks before the growing season. So two key things to understand here is that these yield outlooks, they are based on two primary data sets. One is the long lead forecast of ENSO, which is provided by NOAA Physical Science Laboratories. And another data set that we used is the historical crop yield data. Those are often provided by the National Agricultural Ministries and compiled by FuseNet, quality control, and so on. So here on the right is an example of a long lead ENSO forecasts, which was generated at NOAA PSL, NOAA Physical Science Laboratory, in September of 2025. And what this shows is the probability of El Nino versus neutral state versus La Nina from September, October, November season, all the way to July, August, September of 2027. So it's about 2 years in advance. We are looking ahead. And what these bars are showing here is the probability of different types of events. So just as an example, as per these forecasts, in the near term, we are expecting higher probability, higher chances of La Nina. And about 2 years from now, we are expecting higher chances of El Nino. So we use these forecasts to turn them into crop yield outlook. So here is an example, more details on the approach. We make use of historical yield data. And what we basically try to do is that we try to convert those ENSO forecasts into the probability of below normal crop yield outlook. So what we do is that we take the historical yield data, detrend the data, uh, calculate a long-term mean. It's about seven-year running mean, and then calculate anomalies. And then using the composite of La Nina versus neutral versus El Nino years, we calculate the probability of below normal crop yield, and then basically apply the ENSO forecast as a weighted to calculate a weighted mean of the uh, probability of below normal yield. There's more details available about this method in the paper, and I'll share a reference to this later as well. But here is an example of what these forecasts look like. So these were generated in June of 2023. And at that time, we were expecting El Nino, higher chances of El Nino in the rest of the season. And this is why in some of the regions where El Nino means below normal rainfall, we were expecting below normal crop yield. So what this is showing is that there is a strong chance of the yield being below normal in Southern Africa at that time. So now in this, I also just wanted to quickly highlight that in addition to ENSO forecast, there is another way of providing these long lead outlook. In this case, we use the analog year. So here's an example for Somalia. What we did in this case, we identified what the upcoming season looks like and how it compares to the historical years. And we found that the upcoming year was going to look similar to these highlighted years in the past. And we kind of make use of what happened during the past to inform our crop yield outlook for future. So I'll skip this and move on to the part of the presentation that focuses on anticipating production shocks during the growing season. And a few things to understand here is that we provide these forecasts each month during the growing season. So we start somewhere like about 5 months before the harvest. We provide another update to the forecast as 4 months, 3 months, and so on. We provide these forecasts at subnational scale. So here is just an example of subnational units in Kenya. So each of the units have its own forecast available. We make use of 4 primary Earth observation data sets: rainfall, reference evaporative demand, NDVI from USGS, and temperature data from NOAA PSL. We convert these data sets into different types of predictors. So some of you may be aware of things like growing degree days, killing degree days, number of dry days, and so on. So we basically use these data sets to form different types of predictors that are linked to agricultural productivity. And for this case, we are using a XGBoost machine learning model, and we apply that to provide forecast of crop yield for each of the subnational units. Here's just a little bit more detail about different types of climate and hydrologic data sets that we use for this prediction. One key thing that I wanted to highlight here is that, as you know, each administrative unit has certain parts of the unit where crop is generally grown. So here is an example for Kenya. All of the places that are highlighted in the blue and greenish color are where the crops are grown. So what we basically do is that we estimate the Earth observation predictors only over these crop growing areas, and then use that for our prediction. So we're basically taking the data and masking it over the regions where the crops are usually grown. So another thing that I wanted to highlight here is that this kind of crop yield forecasting depends very heavily on the quality of the crop yield data, the historical crop yield data. So in this example, I'm showing the crop yield data availability for different countries in Southern Africa. So you can see that in some countries like Malawi, we have data from, say, about 1983, going all the way to 2022 or so. Uh, and in some cases, like in the Zimbabwe, Madagascar, we don't have that much data available to us, at least as of now. So I just wanted to kind of use this example to highlight that depending on the crop yield data availability, and the quality of the crop yield data, the performance of these forecasts change. And also, the crop yield data availability has an influence on the baseline that we can use to calculate the anomalies of these crop yield data. So I'll talk a little bit more about this in a bit. But just to show you an example of the crop yield forecast. So in this case, I'm focusing on the crop yield forecast we made for Southern Africa region in April of this year. And here is just a map that shows the uh, uh, anomalies of different Earth observations that are used as predictors. So we got rainfall here, uh, accumulated number of dry days, NDVI, reference evaporative demand, and growing degree days. And there are a few other predictors that I'm not showing here. But in general, again, the brown colors, they show below normal anomalies. For temperature, the red color shows the above normal, the blue color shows the below normal. So in general, what this shows is that based on different predictors, we were anticipating that rainfall was generally normal or above normal. In some cases, the temperature anomalies were above normal and so on. So these are basically the condition of climate based on different predictors. What we are trying to do now is to convert this all into forecast of yield. So what this next figure shows here is the forecast that we provided for crop yield in Southern Africa. So again, we're trying to combine all the information from different climate predictors into one yield forecast, which can be directly applicable for acute food insecurity. So compared to a 2013 to 2017 baseline, we expected the crop yield to be above normal in Southern Africa and slightly below normal in Angola, parts of Zambia and Zimbabwe, and so on. Another thing that I wanted to highlight is that I'm showing the same map, but as before. But here we have masked some of the areas uh, from our forecast, and though that masking is based on the performance of the forecast. So what we also do is we calculate the skill of how skillful these forecasts are, and based on that skill, we mask out those areas where we consider our forecast to not be very skillful. So this is why parts of Zambia, parts of Zimbabwe are masked out. Another thing that I wanted to highlight, which is kind of key to understand, is that often these forecast anomalies, they are very much dependent on the baseline we are using. So here, when we use a baseline of 2013 to 2017 versus a baseline of 2018 to 2022, we get slightly different anomalies in each case. So I'll end my presentation there. I'm almost about out of time, but I just wanted to kind of try to focus on the key lessons from this presentation. Uh, this presentation focused on providing an example of how climate predictors are used to anticipate production shocks. We use ENSO forecast. We also use multiple Earth observation and machine learning models for prediction. Uh, and crop yield forecasts, they are presented as anomalies related to historical baseline period, and changing the baseline can impact the interpretation of the results. So with that, I will just conclude my presentation here, and I look forward to any questions that come my way. Thank you so much for your attention.
Thank you, Shrad. I just like to acknowledge what a fascinating case study you've presented. I'm sure there will be questions there were some technical elements there that I think we may anticipate some follow-up questions, but thank you so much
Definitely. Thank
for
you.
your presentation. Let's keep moving, and I'm delighted to welcome Catherine Jones, who is a climate and disaster resilience specialist from just across the ditch, as we say, over here in the Pacific, from New Zealand, with over 15 years of experience across climate change, food security, and livelihoods sectors in both humanitarian and development contexts. She's currently working with FAO, or Food and Agriculture Organization of the United Nations, focusing on disaster resilience across the Asia Pacific region. Incredible work. I think she's going to highlight it. So I'm just going to hand on over to you now, Catherine. Thanks so much.
Thanks to you, Rebecca, and it's always good to have another accent that's familiar. I just want to pretense as well. If anyone finds what I am saying hard to understand, because New Zealand accents are not the most forgivable, so do feel free to write into the chat if you need me to repeat anything or to go over any of the details. But I just want to say a big hello to everyone. I'm going to be presenting today. I think it's quite a nice fit of speakers because I'm going to be basically utilizing what Sari and Shad have been talking about, is bringing these early warnings and anticipatory action to life. So I'll do my best not to repeat what they've already really clearly highlighted, but complement moving forward. Now, as Rebecca highlighted, I really focus on the Asia Pacific region. So my examples and what I draw upon today, 100% from there. So hopefully you can resonate with it, and those who are from the region, hope that it helps inspire you as well. So without further ado, I just wanted to complement what my other speakers have been mentioning as well, is there is in the Asia Pacific region, we're known to be one of the most disaster prone in the world. You name it, we have it. Looking across the region, droughts have become more common, and models are predicting around 40 to 75% increases in both frequency and severity. We're seeing about 20 to 30 tropical cyclones and typhoons come through the region. In the Philippines, just last year, they had 6 typhoons consecutively, one after the other, come through the country. And we also, I'm here in Bangkok in Thailand. This is where I am situated. But right in my neighborhood is Vietnam, where they get the most storms making landfall each year, 2.6 on average, which is the most out of any country in Asia Pacific. We are seeing increased hydromet events happening here in the region as well, flooding in particular. Last year alone, it impacted over 9 million people, particularly around Afghanistan, Nepal, and Pakistan. And a really interesting new phenomenon, I think, that's been happening over the past 5 years that also Sari introduced as well, is heat waves. We've seen some of the hottest years on record here, and particularly in Southeast Asia, where we saw in 2024 record temperatures hitting around 42 to or up to 53 degrees as well, which is well above the normal kind of 30, 31 degrees that we experience here. So heat waves are becoming more of an issue in this part of the world. So how does this impact food systems? And this is something at FAO that we're looking at really intensely across all the different governments that we serve. And we've managed to do some analysis across the region where we're seeing, for instance, in the Mekong Delta, because of drought and heat waves as well, we're seeing increased saltwater intrusion. This can cause a decrease of up to 10 to 15% of rice yields. In severe cases where, for instance, the 2015 or 16 El Nino, which Shrad also highlighted as a key factor of, instigating drought, we saw up to 20 to 50% decreases. Floods in Bangladesh can inundate large areas of cropland and can impact, we've seen, up to 60,000 hectares of rice. And this not only threatens economic income from a lot of the families who rely on this as for subsistence living, but also food security as well, which Sari really, I think, adequately put us into a really good frame of mind for thinking about today. Just also, as I was mentioning, Vietnam, sadly, at the forefront of typhoons. They can lose about 42,000 hectares of rice and about 500,000 tons of production as well. So it's just crazy the numbers that we're seeing with these climate events over the past few years. Now, an interesting one that has come out of some recent research as well is on the heat waves and how this impacts livestock. We've seen 4 to 5 degrees more can reduce livestock feed and intake and growth and suppress immunity, which can then lead to lower milk yield, lower weight gain, and as well as fertility issues. So this is really interesting, particularly in cattle and buffalo in the region, which are also really key livestock for rice production. So seeing these correlations come through, particularly as heat waves is a relatively new risk in this region, has been interesting to see how we mitigate that moving forward. Then, of course, we've got climate loss valuation for temperature and rainfall can also impact aquaculture, where we've seen huge economic shocks in Bangladesh. And then finally, we've seen recent evidence that shows extreme weather events can lead to local prices spiking. So, for instance, we saw in India, due to, I think, floods that happened out there, an 89% increase in the price of onions, for instance. So, we're seeing those fluctuations also come through economically. Now, I know that's a bit depressing to think about, that these climate hazards can lead to production losses, reduced protein availability, and food security. We see higher food prices and threatening both local and nutrition and export income. Very depressing to look at, I can understand, but I want to give some hope. Well, all of these risks I talked about, drought, flood, typhoons, heat waves, they are predictable. And that goes very well with the theme that we've been discussing today, is really harnessing early warning systems to safeguard lives and livelihoods as well as food security moving forward. So this is what I've been working on for the past 10 years in particular, is trying to understand how we can use these early warnings. And I'm going to take you to how we've been developing this on the ground. Now, kind of looking at the state of play of early warning systems in Asia Pacific, particularly working with governments, we see that various countries around here have early warning systems in place, but usually have uneven coverage with variable lead times as well. Existing systems are also more focused on monitoring drought, monitoring the flood, and a little bit less on reaching last mile. And so how do you translate that information to farmers or fisher folk who need it the most and need to act on it? So it's ensuring that end-to-end communication line. Public trust in these systems need to also be built. We find with some countries, a lot of people really trust these systems, and once they receive an alert, will fully put their funds or their actions into it. However, in other countries, we find that there's a little bit more skepticism, particularly as the climate becomes more variable. In our region, we have very strong early warning systems for more sudden onset shocks like floods and typhoons. But if you're looking at drought or heat waves, for instance, still very underdeveloped and still being very much teased out at the moment, particularly around combined drought indices and how we go about activating anticipatory action for that. Then we also see, as I was mentioning before, community engagement remains very limited. So that science to action gap is very evident, I think, here in the region at the moment, which we're trying to close. So how are we improving these systems and working with communities and governments? So we're aiming to improve early warning systems. So this is developing combined drought indices. So we've recently been doing this, for instance, in Afghanistan, where we're learning that using temperature and rainfall anomalies has been really important, looking at the nowcast, but also the 3-month forecasts and combining these together to understand how could this impact upcoming production, but also livestock as well. And we're still doing improvements there to see how we can include soil moisture as well as vegetation indexes as well to predict these drought events, as also Sari and Shad were mentioning, for around a 3 to maybe up to 5 months lead times. We're also integrating typhoon and flood models at the national level, so improving these systems on the ground, so ensuring that we have rain gauges or supporting local data points, but also marrying that with global spatial data such as GLOFUS, which is a tool that you can easily get online and very easy to use, where you can see where potentially a flood could come into a certain river basin, and you can monitor that on a daily basis. As also Shad was mentioning, we're looking into AI and machine learning to increase lead times, build algorithms, and support capacity for more what we call impact-based forecasting. So not looking at just saying, hey, a cyclone's coming your way, it's saying, hey, a cyclone's coming your way, but 20% of your crops could be harmed if you don't do anything. So really seeing weather and climate data come together with damage and loss data, so farmers and fisherfolk have a better idea of what that weather means for their livelihood. And then also looking at supporting streamlining early warning dissemination. So again, that messaging, making sure it's consistent, making sure that people are not only getting the science, but understanding the science. And that brings me to my next point here is bridging the science and community. So we're really looking at investing in community access, awareness, public trust, but also really emphasizing the dual benefit of early warnings as well. People often associate them with disaster. And we're like, sometimes if we know a good rainfall is going to come, some farmers want to know that and be able to capture that extra rainfall to be able to store away and keep for maybe irrigated systems and so forth. So having information not only for the bad, but also for the good times that will potentially support farmers or fisherfolk. And then also we're looking at developing new technologies, particularly in countries like the Philippines and Mongolia, where social media platforms have a lot of range and we can access a lot of people in rural areas as well, and looking at attaining feedback loops such as a form of ChatGPT to connect with farmers, but also give them agromet information. And then talking about anticipatory actions, I'm loving that this has come up a few times today, so I'm going to be very quick here. But it's basically a part of the disaster risk management that we're seeing many governments get into as well. And I'm going to explain one case study from the Philippines where we've activated this most recently. But it centers around 3 pillars, and the first one being forecasting and triggers, which we've talked about a lot today. So basically finding that alert system, so kind of like a smoke alarm that goes off once the smoke comes through. That's what we're doing with weather and climate data. So understanding when the smoke is coming out for a drought or a flood, and enabling us to then target people quickly, the most vulnerable, and do anticipatory actions. So do mitigative, preventative-based initiatives based on the alerts that have come through. And that also needs to be tied most of the time to flexible financing and enabling us to move quickly to be able to protect those ahead of the shock as well. So it's about pre-positioning financing or even pre-positioning items that can be rapidly distributed once that trigger goes off. But in essence, how you can think about anticipatory action is it's that time between a warning and impact. So after impact, it's usually response. Before the warning is usually preparedness, but in between, if you have that action, kind of the warning go off, and between the action, the impact, sorry, that's when your anticipatory action comes through. And then also what's really important is to think about targeting. So sometimes this can be a bit tricky depending on the country that you're working in, but we're increasingly working on using social protection systems and an FAO, of course, farmer registries. So we're working with a number of countries to develop and digitalize their farmer registry systems that will then enable us, if a trigger goes off, to quickly know where, with mapping it against vulnerability and risk information they are, and how they're receiving that information, but also being able to provide that anticipatory support. Where we don't have those systems in place, for instance, Myanmar or Afghanistan, and even to some extent in Pakistan, we can use what we call the integrated phase classification tool, which is a tool that allows us to understand which areas are food insecure. And this is something hosted within FAO and WFP together alongside a lot of other partners who feed into this process. So very, very quickly on anticipatory action, I just wanted to kind of highlight what can be 4 more minutes. Okay, I can be quick. What can be predicted and what cannot. With anticipatory action, there's been a lot of work done on typhoons, floods, droughts, as I'm mentioning, volcanic eruptions, but also Zud, which is a very unique risk to Mongolia, severe winter season, and heat waves. We're still seeing it being explored for landslides, diseases in particular, both for animals and humans, forest fires. But as also Sari was mentioning, conflict and displacement are also being looked into, but it's an ethical issue sometimes because being able to predict conflict or displacement can cause some issues if that information gets into the wrong hands. Now, very quickly, I wanted to provide you with a real example of how anticipatory action has played out most recently in the Philippines ahead of Typhoon Man-yi in Catanduanes. So it's a small island in the north of the country. So what happened is we have a two-step trigger model. So that's the alert smoke alarm that I was mentioning before. So essentially, we were looking at 6 typhoons that had gone through the countries, as I mentioned before, but we managed to capture the super typhoon that was going to hit directly into Catanduanes. So we had a readiness trigger, so 3 to 7 days prior to the typhoon making landfall, we're already monitoring it. And the threshold is around a category 2 or higher is projected to hit that particular region. So on the 13th of November 2024, we saw that trigger go off, and we saw around 5 days it came into our Philippines protection area where they have to start monitoring it through PAGASA, their national Met service, and it started to raise the alarm bell. So that enabled us to get a bit ready. Then it activated shortly after, the day after, because then it hit into quickly into the 42-hour period. And this threshold is within 3 days before landfall or sooner. The predicted number of total damaged households in that area is a 50% probability, or 50,000 households will be totally damaged, or around 85% chance of 80,000 houses will be totally damaged. Sorry, there's a 0 missing there. So it's using impact forecasting as well. So we were able to use the climate and weather data to say, okay, this typhoon's heading your way with a certain wind speed that will damage households. So then that activated our system. And this is a trigger that is used by a range of different partners, not just FAO, hence why it's not agricultural based at the moment, but we will be moving more towards using, instead of houses, rice and crop yields. So that's our next step, but I won't go down that rabbit hole quite yet. So what did we do based on this information? So we knew the cyclone was coming, or typhoon was coming. So when we had the readiness trigger go off, we distributed early warning messages. We reviewed our operational and logistics situation particularly for our cash transfers. So once that action trigger went off at that 72-hour period, we then distributed multi-purpose cash transfers to 280 or just over 2,800 farming households. And then we also evacuated nearly 300 boats with community cash grants. And this was also delivered through the government's cash and food subsidy for marginal farmers and fisherfolk program. And we used their beneficiary list. The community cash grants were designed mainly to evacuate the boats and evacuate fishing gear, whilst the multi-purpose cash transfers were more for household usage, where they have a choice of how they protect themselves ahead of the shock. What we found as well is we used a blend of build and fuel financing. So what we mean here is we used some funding to build the system in the peacetime, so without the typhoon coming, as well as then we had pre-positioned funds in place to fuel and enable those cash transfers to go out quickly once that trigger goes off. So that was done at the country level. However, I just want to emphasize that with this fuel financing that's pre-positioned in countries, it only makes up 2% of humanitarian financing to date. So we hopefully will see that increase over time, but yeah, still makes up a small amount today. Now, this is my last slide, so I promise I'll wrap this up quickly, is why do we invest in these approaches? So we've had some really great learning come out of the Philippines case study, where we've seen economic benefits. So boat owners who received the cash transfers 3 days prior to the typhoon making landfall, were back at work just 5 to 6 days afterwards. This is twice as fast as those who received rapid response after the shock. And they took around 11 days and nearly 3 times faster than those who received no support and were still waiting on later response. We saw damage and loss recorded on the boats were 3.5 times lower, and the estimated repairing costs for anticipatory action beneficiaries were around 150,000 less, or less than it's like 573,000 for non-beneficiaries. So we're seeing definite big damage and loss and economic benefits of this, but there's also social economic impacts as well, where we saw over 85% of households in anticipatory action recovered fully within 1 month post-shock versus only 67% of traditional response households that took 2 to 3 months to recover. And we also saw over 85% of beneficiaries avoiding harmful coping strategies. But what's really important and exciting in the Philippines is we've seen lately the government has passed the Bill of Imminent Disasters, endorsed just last month, and this will enable their local government units to do their own anticipatory action moving forward. So all these studies, all this hard work has seen us now seeing governments really investing into their disaster risk management and seeing anticipatory action as a critical tool within that. In other studies, we've also seen as well that for drought and floods, we see positive mental health outcomes also come from acting early and reducing the stress of families as well, stabilization and even improvements in diet diversity scores as well, which I can share more of this information and data if you're interested, if you want to deep dive a little bit more into the impact of anticipatory action. And on that, I think I have concluded. Yeah. Sorry for taking a bit longer, but back to you, Rebecca.
And that was a really helpful case study, and thank you for stepping us through a very contemporary analysis, particularly in the Asia Pacific region, and acknowledging our Filipino colleagues and friends that are online that have lived through those recent experiences as well. We have a couple of moments for a final question to all panelists, and I think it's a really great landing place. And that question is, how do you translate this material that you've been covering today into your public health curriculum? Can you give a quick example to inspire our colleagues before we wrap up? Sari, can I hand to you?
Sure. This is a hard question. I mean, what we're touching on is that everything is kind of intersected, in my opinion. I mean, one of the things we talked about was how crops with climate change are losing micronutrients, and we're already experiencing micronutrient deficiencies across the board. Right. And so, it's hard because we're talking about food systems, which are not health systems, but they impact our health systems, which means that we do need to have a more closer relationship between our health systems and our food systems to make sure that people are staying healthy. And so I guess maybe part of the answer is that we need more health experts advocating within the climate space, within the food space, to be ensuring that we're going to be able to remain healthy or achieve healthiness through our food.
Thanks, Sari. And there was a call to action in there as well. So thank you. Shrad?
So thank you very much for that question, and definitely a hard one. I think my hope is that at least the presentation that I described helps us kind of get a better sense of the availability of different types of climate data there is, particularly for the regions of the globe that are not as well observed. The density of the in situ station is little. So my I guess my hope is that one might get inspired by this presentation and try to incorporate different aspects of climate. So not just simply rainfall, temperature as well, vegetation conditions, evapotranspiration, and so on, soil moisture, and so on, and kind of try to get a more comprehensive understanding of how climate might impact food insecurity and public health directly. Thank you.
Brad, and your point on being inspired, I can see from the web chat that they're been very helpful session, and I'd like our presenters to take a pause and look at the feedback because it's very positive. Catherine, what are your thoughts?
Thanks so much. My thinking is I've seen people use early warning information for food security and seen the positive health outcomes that have come from that. I've seen a lot of people, I think, trying to see how, particularly with anticipatory action, they want to see improvement in diets. But for me, I'm like, if I keep it stable, I've done what I needed to do. If someone can ride through the shock and still keep food on the table and have all of those key elements that Sari was mentioning, that's worth what we're doing. Because often, and too often, we see with these shocks, people are slipping further into poverty, further into food insecurity. So how do we ensure we can protect them from these shocks that are going to come more frequent and more intense? So when you're thinking about your public health curriculum, think about how can we inject early warnings into this? How could you maybe use that to maybe do vaccinations earlier if we know that there's going to be heavy rainfall, and you could maybe go out and do a malaria run or something and things like that. My partner's a doctor. He's probably going to tell me off for getting all of that part wrong. So apologies to all of the doctors and nurses here. But if you see what I mean, like we can use this information to protect people and have better health outcomes. We're facing an increasingly challenging environment and a challenging climate, but there are tools we can use to still protect the most vulnerable. So yeah, we'll just encourage everyone to think about ways that it can be integrated, and really hope that this is the way of the future moving forward. We have the technology, it's just applying it and understanding it is what I'm seeing is also the big issue.
Catherine, thank you so much. You've finished this presentation and conversation off so beautifully. And there's lots of applause in the chat there, so please take that moment to enjoy that support. And thank you everyone for joining again today. Back again with session 8 coming up. And wherever you are, take care and look after each other. Thanks so much.
Thank you,
Thanks so
everyone.
much, everyone. Thanks, Rebecca, too. Great moderation.
Thanks, everyone.
Thank you, Rebecca. Thank you all.